welcome to the State of Code Coverage for Kotlin. First of all, let us introduce ourselves, and I'm happy to introduce my colleague, Evgeny Mandrikov, who is Principal Software Engineer at Sonar. He is also, by chance, JCoco project co-lead. So today he is going to be responsible for the coverage part of our talk.
And I'm happy to introduce my colleague Marharyta, Staff Software Engineer at Sonar. He's also Kotlin Google Developer Expert. So she's going to be responsible today for the Kotlin part of our talk. Please welcome. And let's move on. As we say it, we both work at Sonar. Sonar is a great company. I hope some of you use our products like SonarQube, SonarLint, SonarCloud. Let's make a quick check. Who knows this company, who uses our products? Don't be shy. Wow, that's impressive.
And
Don't
we have stickers for you. Yeah. So after the talk, you can come and grab them.
Don't be shy. You can use our products and you can hate them. We are fine with that because today our talk is not going to be at all about this product. And whatever we are going to tell you today is our own opinion. Company can only dream that they own our opinion. Let's move on.
And there is one more important thing that you should know about me. I am Ukrainian. I was born and raised in Kyiv. And today you probably heard that my country is struggling. We have problems with our nearest neighbors. And if you feel like you want to support Ukraine fighting for our freedom, here is a link to the Trusted Charity Fund. So if you want, you can scan this QR code and make some donations. Oh, thanks, didn't expect it to be like this. And the most serious and the most important part of the talk is done. Now, let's have some fun.
Apparently, I'm going to be also responsible for the fun part of this talk.
I think we're all doomed here now.
Sorry for that. So, let's move on. Marharyta, today we're going to talk about code coverage. What's code coverage?
What Wikipedia says about code coverage you can read on the slides. To me, code coverage is a metric that tells you which amount of code was executed when you run your tests. And in my team, we like code coverage. We use it a lot. And here is one of the projects, Sonar Kotlin, one of the projects that we maintain in my team. It's static code analyzer for Kotlin. So if you're using Sonar with Kotlin, you're probably using this plugin. And there is one interesting thing that happened to this project. A long time ago, it was written in Java. But before I tell you what happened later, I want you to ask a question. Raise your hands if you want to target the level of code coverage 60%. Like, at least. Okay, maybe 70, 80, 90, 100, 120. Yeah, the best, yes. So in our team, we have 95%, and we were able to maintain it long time ago when it was written in Java. And then we rewrote the plugin in Kotlin, and we could not manage to have 95%, so we had to lower the target to 85% on the new code. And today, you're going to learn why things like this happen.
So, before we are going to learn today's state of the things and code coverage for Kotlin, let's remember a little bit, recall a little bit of a history. Back in time, in 2003, there was a tool called Emma. This tool is nice. It is, from my knowledge, the very first code coverage engine for Java. What's funny, at that time, it was also used in Android SDK, prior to appearance of other tools. And then there was another quite old tool, Cobertura. Both are not very well maintained nowadays. I don't think that they work for Kotlin. They don't even very well work for Java anymore. So time goes on. In 2007, we get a Clover. It's a source-based code coverage tool, so unfortunately, it's Java only. It doesn't work for Kotlin. In 2008, we get Android 1.0. In 2009, new tools appear. Namely, we get JCoco, Java Code Coverage Engine, no Kotlin at that time. We also get JetBrains Coverage Engine from the creators of a Kotlin language. It also works for Java. We also get AP test, so-called mutation testing tool. We're going to see that later. In 2013, we introduced in Jacoco offline mode to be able to run code coverage measurement for the Android applications. And in 2016, we get a Kotlin 1.0. You might wonder why I focused on those Java-only based tools. Well, as you know, Kotlin on the JVM compiles into the bytecode, Java on the JVM compiles into the bytecode. Those tools, they do analyze bytecode. So we might make a logical conclusion. Everything what works on the bytecode level, not on the source level, like Clover, should also work for Kotlin, right? And that's exactly what happens. People start to try using those tools for Kotlin. They start to use Jacoco for Kotlin. And well, it turns out after a while that it's not as easy as it is. And those tools, they do require some modification in order to properly work with the Kotlin. So in 2018, we do the first commits in Jacoco to properly support Kotlin. What's also funny here is that the very first commits were based on the ideas suggested to us by JetBrains, by the creators of Kotlin language. So thanks to them, we had quite some productive cooperation there. In 2021, JetBrains decides to introduce a new thing for code coverage for Kotlin, so-called Cover. But don't be fooled here. Cover is not a new code coverage engine. It's just a Gradle plugin. Cover under the hood is still based on something very well known and existing there for many years. By default, it's based on JetBrains coverage engine that initially was developed not at all for Kotlin, but for Java. Also, this Gradle plugin allows you to use another code coverage engine, Jacoco. So there is actually two in one. And time goes, what's happening? And time goes, now we are in 2024. What's the current state of code coverage? That's exactly what we are going to focus.
Yes.
So let's start.
Let's start comparing the tools. So
But which tools we're going to pick? Obviously, tool of my choice is Jacoco. We're going to today look at the Jacoco.
you're a maintainer, come on, that's obvious.
Yes, I should pick it. So with Jacoco, you probably already know, or maybe not, but we get a report like this. It shows us missed branches, not missed lines, but executed lines are green. We also get some metrics on the package levels. Again, some mixed branches, missed instructions. Pretty neat, right?
Yes.
So,
and Pikachu will represent it, yeah.
okay, if you say so, Pikachu apparently today gonna represent Jacoco.
Yes, and we think that's not fair to only talk about Jacoco today. So the second tool that we picked up is JetBrains Coverage Engine. So you can see that report looks pretty similar. We can see percentage for class, method, branch, line, instructions, and it also shows what is covered green, what's not covered is red. We don't see it here. And I think it's Bulbasaur who will be representing it.
Don't look at me, I'm not in this world. If you say it's Bulbasaur, it's Bulbasaur. And let's don't stop at two. Let's pick a third tool, which is ptest, which is not actually just a code coverage engine for Kotlin or Java. It's so-called mutation testing tool. This tool, it executes your tests. It measures code coverage induced by those tests, and then uses this information to associate tests with the main code. And then it tries to modify your main code and execute associated tests. If after the modification of main code test still passes, then something fishy here. Then probably your code is not very well covered by a test, or test is wrong, etc. And so on. And this is exactly what we can see in our little hello world example. We have some tests. All other code coverage tools, they just say it 100% coverage, but mutation testing says, well, if on that line we will modify something, what we will? Yeah, if we will remove condition, then actually all the tests will still pass. And this indicates that actually we forgot assertion in our tests. So pretty interesting, pretty neat too. Let's try to use it as well.
Yeah, and now it's time to compare them. Let's fight. But there is a problem here. I don't know how to compare them because they're so similar and they're so different at the same time, and I've never done a comparison for the tools like this. Do you have any idea what we can do?
I also never compared tools. This is first time we are doing it. But I do have an idea for you. while developing Jacoco, we test different language features, how do they interact with our code coverage tool. So maybe we can just go through some language features and try those three tools.
I like this idea. Do you have any language feature to start with?
Yes, I have. I pretty much like try with resources in Java. It's a wonderful feature in Java. I think Kotlin developers also should be interested in this Java feature, because in Java you can specify multiple resources, and in Kotlin with a use you can only specify one resource. Let's have a look at this one, okay?
Okay.
So here is a little example. I have try with resources in Java. I have some resource, I open it, I read something from it, pretty simple, right? And I can write a simple test that I actually read something from this resource. That's easy. Like this. If I execute code coverage tool like Jacoco, we are going to see that, well, everything is covered. I executed all lines, there is no branches, nothing, everything is green, 100% code coverage, as everybody here wanted.
Good for you.
Okay.
Let's try JetBrains coverage engine.
Let's try.
Let's hope it's...
Oops, clicker works not very well. It's also all good here. All lines are covered, everything is green, everything fine.
What did you say?
All lines are green.
Do you agree that all lines are green? Can you look at the line 10?
It's green.
Okay. Look at the branch percentage.
Okay. You're forgetting that I'm colorblind, you know?
Yes, I always forget that you're colorblind. So for him, actually line 10 looks green. And that could be another way of comparing the tools, color-friendly UI, and looks like all the tools are not really good there. But thankfully, we have percentage, and we can see that there is some missing branches.
Yeah, what's funny is that I even have difficulties with Jacoco code coverage report, even though I develop it. But, well, that's life. Let's move on. Our third tool is ptest. And ptest is pretty happy with all this. Again, it tells that everything was tested.
Yeah, okay, now I'm a little bit confused. It seems to me that everything indeed was tested, but why JetBrains coverage engine tells that it's yellow?
Let's recall what I said earlier, that all those tools, they've been developed to analyze the bytecode, not the source code. So actually, they perform analysis of a result of a compilation. And in order to understand what's going wrong here, we need to look at the result of compilation. So if we will compile this example, we can use a standard JDK tool to decompile it, but not into the Java, but to see the human-readable form of a bytecode of it. For this, we can use a JDK tool JavaP with the two options, -v verbose, -p show me privates. Those two options, I like to call them show me everything, JavaP -v -p. And here is the bytecode that we are going to get after compilation of try with resources. If you look at it, it should be pretty obvious.
So you cannot distinguish green and yellow, but you can read this.
Yes.
Let's zoom it a little bit, maybe.
Sorry, I need to zoom, right? Okay. Now it's better, right? We zoom it in, it should be obvious why code coverage, JetBrains code coverage engine doesn't work.
Maybe let's highlight important stuff.
Okay, let me explain. So what happens under the hood of Java try with resources? We all know that resource, we open it and it will be magically closed once we leave the try with resources block, right? In order to do so, there are going to be some calls of a close method. And well, we need to be sure that resource is closed, so we are going to close it 2 times to be sure that it's closed. That's why we see here a close method called 2 times. Well, that's a joke. Of course not. This code compiles into the construction which looks like try finally. And in order to implement try finally on the bytecode level, we actually need to introduce some code duplication. When exception happens, we need to close the resource. When exception doesn't happen, we also need to close the resource. So there will be some duplicates in the bytecode. Also, we need to check that resource is not null, otherwise null pointer exception is going to happen. So there is some branches null checks. And that's exactly what JetBrains coverage engine is missing. JetBrains coverage engine sees those null checks and doesn't see the value being null, so believes that some branches wasn't covered. In some sense, JetBrains coverage engine is right. The code is there in the bytecode. But in some other sense, it's wrong because we never wrote those null checks. They've been generated by the compiler. So the goal of code coverage engine to adapt to this and to actually filter this out and to tell to the user a report which is as maximum as possible close to the source code that users write. So we don't need to test the compiler. Let's test our code, right? That's exactly what we did for Java with Travis resources, and that's exactly what we've been doing for some Kotlin features in Jekoko. We've been writing filters.
Yeah, that's nice that you mentioned for Kotlin features, because have you noticed something fishy here?
What?
Like Travis resources. We are at the Kotlin conference.
Really? But I'm a Java expert, sorry.
Yeah, so let's start with some Kotlin features. Do you have something Kotlinish?
Yeah, okay, let's talk about Kotlin if you want. What about when expression on a string? Is it a Kotlin feature, right?
Yeah.
Okay,
Yes.
let's talk about it.
Let me write the code this time.
Okay, this time you write code, fine.
So I implemented this simple stupid when expression with, you see, 4 branches, and I implemented 4 tests. So I expect everything should be covered. Yes, 4 branches, 4 tests. What else to cover? I don't know. Let's run Jekoko here. So, yoo-hoo, everything is green, 100%. JetBrains coverage engine, also everything is green.
Hold on. This time you asked me to not look at the colors, so I look at the numbers, right? Like you said 4 branches.
Come on, who cares? It's still green.
Okay, fine, but something fishy here, but that's fine. Okay, maybe they filter it out a little bit more than needed.
Yeah.
Let's move on. P-test.
Okay, that's interesting. P-test says that some mutants survived. Let's look at them. So removed condition replaced equality check with false. So there are some equality checks that they replaced and they were killed, but some of them survived. I don't understand. I didn't wrote so many equality checks. Can you maybe explain me what happened?
You never wrote any single equality check, right? You wrote switch expression. But pretty much the same thing happens as before. Let's have a look at the bytecode. So here is the bytecode. This time I will zoom in faster. So here we can see, indeed, there is a switch. But what we could also notice here is that switch is performed not on a string. Switch is performed on a hash code of a string. This is a pretty efficient way to implement switch by string. We check the hash code. With a high probability already on this step, we are going to identify which case it is, because strings are having distinct hash codes. But we also know that multiple strings can have actually the same hash code. So we also need to be sure that we made the correct choice. We also need to introduce equality check. And that's exactly what p-test tells you.
Do I need to write tests for the strings with the same hash code now?
Yeah, you forgot to do this. To please p-test, you need to write such tests. But as I told you earlier, let's don't test the compiler. Let's test your code. And in your code, there is no such trick. So p-test needs some filters implemented, like they've been implemented in Jekoko and JetBrains coverage engine. But don't worry, actually, I have a good news for you. There is a tool called arcmutate. It's a commercial extension to the p-test, and this extension is claiming that it has a support for Kotlin. Basically, this is extension that brings Kotlin support to p-test.
So technically, if you have enough money, you can transform your Charmander into Charizard.
Yes, and here we see the report. If we activate this extension, we see that exactly the same code, exactly the same tests, everything is fine.
That was the only reason of introducing Pokemons here.
Okay, let's move on, right?
Yes, okay. I think this time I need to be responsible for the examples, because all your examples are Java related, and even switch when was in Java. It's not Kotlin feature.
But it exists in Kotlin, right? It's
right.
A Kotlin feature. Okay, you choose now.
I cannot change you, but okay. Inline functions. And I have a feeling that Jekoko can tell us something about inline functions.
Try it.
Let's do it. So I wrote some inline function with lambda, of course, because otherwise compiler says the warning that it does not make sense. I wrote a test, and they expect everything to be covered. Yes? Oops, I think Jekoko is broken here.
Shit happens.
So it says that the body of inline function was not executed, yes?
Yes.
Okay, let's try JetBrains coverage engine. Yoo-hoo, all green. So probably I am not that was fine. And let's try with arcmutate. Oh, unfortunately, we don't have any report from ArcMutate.
You know what? Your code is so simple. Come on. That's what ArcMutate tries to tell you. This code doesn't
it's
need...
not code of the level of Google Developer Expert.
Yes, not a Google Developer Expert code. ArcMutate tells you don't write tests for this code. It doesn't need any tests. Can we complexify it a little bit?
Okay, what do you
You
suggest?
have a lambda, make a return type nullable.
Okay, I think this one I can do. So I made the return type nullable. I introduced null safe call operator. And I wrote 2 tests now, because now we need to check the null and non-null value. So we're not going to run jQuery because I think it's still broken. Let's run JetBrains Coverage Engine. And now we broke JetBrains Coverage Engine too.
You see this, right? Because I still see everything green, but numbers are not lying. The branch coverage is 0 now.
Okay, and still no report from ArcMutate. So technically, your suggestion makes things worse. You not only didn't get the report for ArcMutate, we actually broke the JetBrains coverage engine.
You need help?
Yeah.
Yeah? Okay.
Yes.
Unfortunately, as name suggests us, inline functions, they do inline into the call sites, right? And that's exactly what ArcMutate cannot cope with, because all the call sites are in tests. And I told you earlier that ArcMutate doesn't change the tests. ArcMutate changes the main code. But there is no calls of inline function in the main code. All the call sites are in tests.
So we can
we move call sites out of a test?
Yeah, that's, I think, a good idea. So let's do it. And let's run it again. JetBrains coverage engine is still broken. But we have a report from ArcMutate, and it's green. Yoo-hoo.
Cool.
So I think I still need some explanation what happened to JetBrains
coverage engine.
Yeah. Can we maybe simplify this name somehow?
GB?
Okay.
So you know what we're going to do, right? We're going to decompile bytecode. So let's have a look at the bytecode. Here is our original function. It has a null check, right? There is a null check. We wrote this null check. All good. Here is a call site number 1. Notice something strange in it.
There is no null check here.
There is no null check anymore. So not only inlining happens with inline functions, there is also some optimizer which is going to optimize obvious things like a null check. If in this call site, this never happens. Constant folding, etc., all those optimizations might happen for inline functions. So in the very first call site, there is no null check. Let's have a look at the second call site. There is no null check as well. And that's exactly what fools JetBrains coverage engine. And that's exactly why we never implemented support for inline functions in Jcoco. It's pretty hard to map all the call sites back on the original, because the call sites are not identical to the original anymore.
Okay, so, but if there is any hope?
Yeah, you know what? Yesterday I went back to the bed quite late because I spent some nice time hiking on the Jcoco, and I have a good news for you guys. After, I don't remember, like 10 years of a ticket about inline functions being open, I finally had some time to work on it, and hopefully, if I don't go to conferences, if I have some time to release to code.
Stop, go and fix it. So the only reason why you don't have inline functions because he's speaking at the conferences instead of doing work at Jcoco.
So yeah, hopefully after some polishing, we're gonna get it at least on the same level as JetBrains coverage engine, because it's still hard to map it properly, as we've seen, because of the optimizer.
Oh, there is some hope, you say.
But there is some hope, yes.
Just 10 years. So. Okay, let's continue with Kotlin features. And today is 2024, and it's impossible to imagine Kotlin without coroutines. Like, who is using coroutines these days?
Oh, sorry, I am Java developer.
Everybody. And do you remember when coroutines appeared? I think it was Kotlin 1.1, yes, and finalized in 1.3. So it's a really cool feature, and they really want to test it. Everybody
should support it because, well, it's so old feature, right? Let's try it out.
Let's try. So this is a stupid simple example of Fibonacci sequence, my favorite sequence, with yield. So here you can see suspension points, and there is few tests here. I don't think we need to
Who agree? There is those two tests, and this is enough to cover this code. Like, we check boundary condition. We check that we never, well, enter the loop because we check a first element. We check that we enter a loop at the fifth value. Who agrees that, well, this is exhaustive tests? Oh, okay. Don't be sleepy. I think it's enough.
Yeah, I also think that's enough, so let's check. So, indeed, JCoco says that everything is covered. Let's check JetBrains coverage engine. It also says that everything is covered. Okay, 2 out of 3, it's already a good result. Probably I am good at writing tests. Let's check ArcMutate, who is claiming the support of Kotlin. Oops. So you remember, like, coroutines appeared in 1.3, and you paid ArcMutate to have support of Kotlin.
So apparently, even money cannot solve all the issues in the life, right?
So unfortunately, but maybe after our presentations, they will fix it. No.
What ArcMutate tells us? Just out of curiosity. Like.
So replace equality check with true, survived.
So again, you can guess, we are not going to look at the bytecode, but there is something under the hood of this code what compiler generated.
Yeah, I think we don't have enough time to look everywhere in the bytecode, so it's like your home assignment. If you want, just look what's inside, and you will learn. So, and another thing, like we are here at Kotlin Conf. Raise your hands if you're an Android developer here. Don't be shy. I expected a little bit more of them. But yeah, I think we need to speak a little bit about something for Android. And I think it's Compose. Who is using Compose here?
Well, you see, more people use Compose than Android developers in this room because probably...
There is Compose for web and Compose for desktop.
Yeah, Kotlin multi-platform. So it's a thing.
So Compose. Let's check Compose. Honestly, I'm not an Android developer. So this is how I imagine the composable function should look like.
It probably doesn't make sense, right, to write composable functions like this, but okay.
Let's at least try this. So these are my tests. I checked all the conditions. And this is what JCoco is telling us.
Again, shit happens.
Something like this is green, this is yellow.
Oops.
What happened?
I probably tested the wrong version, and we spoiled the trick, but okay. Move on.
Let's move on. So the same happened here, yes, I think.
No, not the same. Look at this line.
Okay, this one is
It's a little bit red.
So, and the branch coverage says that it's 50%. So something fishy is here. So, let's check. ArcMutate. Yes, and ArcMutate is also broken here. So, I think our coverage tools are not yet ready for Compose.
Well, I had another great news, like 3 or 2 weeks ago on an Android Makers conference in Paris. I also spent quite some time late at night coding the Compose support in JCoco. Oops. And we didn't get a report. We completely messed up something.
So,
but okay, basically, that's probably the report that we should see. And we messed it up a little bit of slides. JCoco got a support for Compose recently, so when I say that something is work in progress, it is not a lie. We have a confirmation here. The next version of JCoco is going to fully support composable functions.
So if there are some stalkers of us from Android makers, you can see that 1 month ago, it was red and yellow, and now it's all green. So looking forward for the next release of JCoco.
Let's move on. Oh, actually, yeah, here it is.
So here it is, yeah. And have you been to the keynote today? Yeah, so impressive.
Not everybody for some reason, but that's fine, that's fine.
Yes, of course, because it's too early, 9 o'clock, come on. So you heard that Key 2 is out now, and we are all super excited. And let's check how are the tools. I don't know exactly, I don't have any examples, but maybe you can tell me if you have tested, if you've noticed anything fishy here.
Yeah, so we've been actually following K2 since alpha versions. We've been testing it actively, and we actually have been reporting some differences. Some stuff been tested in betas, some stuff unfortunately wasn't fixed. We will need to do some adjustments in Jacoco, and hopefully other code coverage tools will also adapt to the Kotlin 2.0, it's fine, it's just released it, we have some time to fix things. So one of examples that was not fixed is a simple, stupid, basic enum. If we will test it with Kotlin 2.0, here is what we're going to see. There is
What
one
am I
red
supposed
line.
to test at line 7?
I don't know. No, actually I know. In Kotlin 2.0, they stabilized a feature which is called enum entries method. And that's exactly what Code Coverage Engine tells us. There is a method that never call it, but you don't again need to test it. It's compiler-generated method.
And
if you look at
other
JetBrains,
tools?
it's the same story.
Okay, and sorry, and for argmutate?
For argmutate, all fine.
Yeah, okay. And so far, we've always been talking about the correctness of the test report. However, we were not talking about the correctness of the observable program, and it reminded me about observer effect that tells us that even the fact of observation changes observable. So, are the programs that we are measuring still correct?
You're absolutely right. Indeed, the fact that those tools, they spy on the code is exactly this observer effect from physics. There is no way to observe how your program is executed without altering its behavior a little bit. And one of the goals of those tools is to alter behavior as little as possible. We struggle a lot to not affect your application, and most of the time we succeed, but to my knowledge, there is at least one where we don't. There is interesting construction, try-catch. If we put inside of a try synchronized block, everything works as long as this code is compiled by the compiler. Compiler is going to ensure that all properties that Java Virtual Machine or Android runtime expect from this code, they are satisfied. One of such properties is so-called structured locking. When you take a lock in certain points in time, you should release locks in other certain points in time, and you need to balance these two things. And all is good if this code is compiled by a compiler. All is good if we will instrument this code with our code coverage tools as long as we instrument result of the compilation by the compiler. But Android developers know that there is R8 shrinker, which actually takes result of the compilation, transforms it, and only then gives it to the code coverage tool. And once this transformation by shrinker happens, it breaks code coverage tools. We are not anymore expecting the bytecode that the shrinker generates to happen in the real life, but it happens, and it has a negative impact. After instrumentation of this bytecode by code coverage tools, we're actually going to break a property of structured locking. If we try this code on the JVM, JVM is going to execute this code, but it's going to complain that such a method cannot be compiled anymore. It's going to be executed.
JIT compiled, you mean?
JIT compiled, yes. This method is going to be executed in the interpreter. It will never leave the interpreter, and this code is going to be a little bit slow, and not a little bit.
But it's not a big deal. It still executes, it
still runs fine.
Yeah.
Unfortunately, if we do the same with Android runtime even stricter than JVM runtime. And Android runtime is going to completely reject such a program. Our usual suggestion for Jacoco users, how do we deal with this situation? You can rewrite this code slightly. If you rewrite it slightly, this is not going to happen anymore. If you change, for example, if you move synchronize it outside of a try, if you change the order, that works fine if you can modify code. It's not always possible to modify code if it's in third-party library, right? So with Jacoco, we suggest our users, well, exclude third-party libraries from instrumentation. You don't want to record code coverage for the third parties. You are testing your code, right? This works well again till we reach Android. Unfortunately, when we run tests on Android emulator with Android runtime, it's not possible to exclude third parties from instrumentation. And here, we developers of Code Coverage tool have no ability to change that because it's within Android SDK. So if you are concerned about this, I ask for a little help. Please go there. There is an issue to allow exclusion of third parties. Please vote for it. Hopefully, Android SDK developers are going to fix that for us, and it's going to help you to deal with such crazy examples. And of course, yes, we should work on properly fixing this structured locking thing, but that's not easy. That's a pretty tough property, and it's hard to fix. It's probably even harder than inline functions.
Yeah, thanks for sharing the link. And it also reminded me that there is another outcome of observer effect. It's performance, because I think the fact that we need to observe, that we need to monitor the code coverage, gives some overhead, and it probably affects the performance. So I was curious to learn how huge is the impact, and I tested it on my favorite projects on our Kotlin, and where we can see that raw test on my machine executes in 57 seconds. With JCocoa, it's 1 minute 20 seconds. With JetBrains Coverage Engine, 1 minute 23 seconds. And with ptest, it's 1 hour, 20 minutes, 7 seconds.
Oh, hold on. Don't be so sad about ptest. This is just a first one-shot measurement. There is no tuning of ptest. It was executed, and that's it, and she forgot about it. Actually, ptest has quite a lot of configuration options. One of those configuration options, for example, to run incrementally. You're not always modifying all your code base. You're adding some code somewhere and some tests somewhere. You don't need to re-execute all the tests. So-called incremental mode.
Yeah, and
so actually, you can tune ptest so that it will be faster than that. Indeed, the very first measurement is going to be quite long, but
yeah, and honestly, I don't think you need mutation testing like on every PR, on every commit. Maybe it's nice to execute ptest only on nightly builds where you don't care whether it's 1 hour or 2 seconds, who cares, and run simple code coverage every time because it's more or less fast. And here we can see that JCocoa and JetBrains are almost on par.
Wait. Sorry, I cannot agree with that.
Of course, you're JCocoa maintainer.
Let me write some micro benchmark. I'm going to pick your favorite Fibonacci sequence. Sorry, I wrote this Kotlin code. I hope it's correct. I didn't use coroutines. Hope you will be fine with that. Please verify, is it Fibonacci numbers?
Looks like it.
Yeah, so all good, right? This is going to be my benchmark. I'm going to run it without code coverage, with instrumentation by JetBrains Coverage Engine, and with instrumentation by JCocoa. And here is what I'm going to see.
And you used JMH, yes? Here.
Yes, I use it pretty well-known OpenJDK tool called GMH, Java Micro Benchmark Harness. I run those benchmarks. Here is my original. Just for the comparison, I also executed no operation when I don't compute Fibonacci, just to see that my benchmark makes sense. And indeed, no operation is faster than computing Fibonacci numbers. That's obvious. And then we instrument this with JCocoa, and we see that JCocoa introduces some slowdown. It indeed introduces the overhead compared to the Fibonacci numbers. And then we introduce JetBrains Coverage Engine. And here, overhead is even bigger than with JCocoa. It's twice times slower. So don't be fooled by the measurement on Sonar Kotlin. It depends. As usual in the computer science world, answer is it depends. Depending on your application, you might be heavily impacted by the performance, or as in case of Marharyta, maybe you wouldn't see a difference.
Okay. So I think we are short on time, and of course there could be much more examples here, but let's look at the final table. So here it is. Of course, it's not exhaustive. There are some things that we can add, but what's the most important thing here, that all these tools are more or less on the same level. Some tools are better in some way, some tools are worse in some way, and they're still improving. And in the ideal world, in the future, we want them all to be green and want them to support all the features and fix all the problems. And to sum up, there are a few words that we want to say at the end. So tools are not ideal. Of course, they will have some false positives, false negatives, and so on, but they're still helpful because, first of all, even when they are not that accurate, they still provide some insights, they still can help you, and even if you see some false positives while investigating them, you'll also learn. And of course, you should remember that all these tools, they're not fighting against each other, as we showed in this presentation. They are all fighting on the bright side, trying to help your code to be better, your tests to be better, and at the end, the world to be better. So don't hesitate to provide feedback if you find something, some bugs, some problems, because this is the way how maintainers can learn and can fix this to make the tools better. And let's be nice to each other, because as you learned today, it's not that easy to write a code coverage tool for the language like Kotlin. So, thank you.